Hello, good morning everyone. Welcome to my talk. Thank you for being here. First thing in the morning. Hope everybody had a good first day. Hopefully not too late of a night. My talk today is on GraphQL, GraphQL Java and Spring. We have new releases from both. A little bit about me. I started work on Spring Webflow. My first contributions were to Spring Webflow. After that, I joined the Spring Framework team. I think around Spring Framework 3.1 were my first contributions. And after that, I've been involved on the web side of things quite a bit. Everything that followed from there, WebSocket, web messaging, WebFlux, RSocket, a lot of the testing support as well I've contributed to. And of course, when it comes to GraphQL, the first thing that you need is a web transport. And so I got involved in that, and it went much beyond that. There's now a lot more to just the transports, but I continue to be involved in the project to this day. Now, a little bit about you. How many of you are using GraphQL and feel comfortable and familiar with it? Okay. And how many are here to just find out about GraphQL and still learning? Okay. So it's about 50-50. Thank you. Just less than 2 weeks ago, we have a brand new release of Spring for GraphQL 1.3. We have some features that I'd like to go over and talk about. At the same time, there's also a new breaking release of GraphQL Java 22, which was in April, just before that, and there are some interesting things in there as well. And last but not least, there's also the collaboration with Netflix that I want to spend a little bit of time talking about, because if you get into GraphQL, this is a sort of a major topic, since there are two very good offerings in this space. Mostly it's going to be demo-driven. So let's take a look at the first demo. So basically, this is a activity app, sort of similar to Strava, if you use something like that, social exercise, sharing with other people. And this is the schema. In GraphQL, we have a declarative language where we can indicate what our types are. And you can see that we have clubs and athletes. These are the two main sort of top-level types. Hopefully it's self-explanatory if you're not familiar with GraphQL. Athletes have a list of activities. That's a one-to-many relationship. That's expressed with this sort of array-like syntax. And then activity is actually an interface because there are different kinds of activities and they have some common fields. So we have the concept of interfaces in GraphQL, and I want to demo some features around that that we've added. And there are three kinds of activities: run, swim, and rowing. And an activity also has a list of comments. So that's again a one-to-many association from activities to comments. And then at the top of that, this is the top level type which every GraphQL schema needs to have for queries. And there are two kinds of queries, and this is basically what we expose to the outside world. You can get an athlete if you pass an ID, or you can perform a search and you can get a list of search items. Now, search items, this is a type that we don't have in Java. It's a union. It basically means you're going to get one of these types, any one of these types back. They don't necessarily share anything in common. So unlike an interface, they don't have any common fields. And again, we have some features around that I want to demo. And then on the Java side, I have very simple record types that match. So for example, this is the club, then there is an athlete, and then the activity is an interface. Then we have the different kinds of activities: rowing, run, swim. One thing you will notice that I want to point out is that the graph of data is not connected. And the reason for that is because in GraphQL, the data that we return to the client is selected by the client. So it's kind of a lazy mode assumption in advance, which means that we should be neutral to whether all of the data is needed, and we should be prepared whenever we have these kinds of one-to-many relationships, like for example from athlete to activities, we should not assume that activities is necessary to fetch. Of course, if it's easy to fetch, that can be fetched, but often if it's more expensive, then you can make that a separate retrieval. So we'll get into all that, but there are basically different ways to handle that. One way is that you can have a nullable list of activities here on the athlete. Another way that it's commonly handled is that you might have a list of athlete IDs, and then if actually we need the activities, activity IDs, if we actually need the activities, then we use those IDs to load them, and there's a data loading mechanism library for that. And then another way is to just not have them included, and we'll register data fetchers for all that. But before we take a look, actually I'll show you here that we have a couple of controllers and they're empty, which means that we don't have anything implemented at the moment. Let's go ahead and start the application, because I want to show you a feature for schema mapping inspection, which is a feature that we have in Spring for GraphQL that lets you know on startup, what's your coverage of the schema? Does your Java code have everything to match to what is in the schema? Because if we don't have that, then at runtime you may end up with queries, and if some part of the graph is not covered by the Java objects or by any data fetchers, then you will basically get null, and if that field allows null, that's kind of a silent, missing data that's being returned. So you'll see here, this is the report, and it's telling us that we have unmapped fields, and that's for the athlete and search queries. So it starts out from the top, it looks at the top queries, and then it tries to find if there are any registered controller methods, or they're called data fetchers in GraphQL Java. And if it finds them, then it continues to search by looking at the return type of those controller methods and kind of compares the graph against the schema to see if there's anything missing. So let's go ahead and add these methods. So I'll start with the athlete controller. Okay, so basically this is a method which maps to the athlete query, and you can see here the ID support. So for example, if I click on that, I can navigate to the schema, and it tells me that this is mapped to the query field in the GraphQL schema. And then if I go back here, I also want to show you, so the query mapping means that we're mapped to the query. That's the type. The field, this is called a field in the schema. These are fields. That's the athlete. If I change that to say get athlete, you can see that it's actually warning me that there's no mapping. Cannot find the GraphQL schema mapping. So it is aware of that. And we have a convention. Of course, if you prefer get athlete, then you can also do this, and that works as well. The other thing that I want to point out is that there's also the argument ID. If I change the argument ID, also it doesn't consider it a match. So that's a nice feature also when you develop. Now this is going to fetch the athlete, but the athlete again has only the data for the athlete, not the activities. So what we want to do is we want to add a schema mapping for activity. and so now this is responsible for fetching the activity part of the graph. So if you look here, we have the athlete, and the athlete has activities. Right. Now the other thing, so let's go ahead and try and start this again. And see what it says this time. Okay, so now it's telling us that we're missing comments, and it's actually aware of the fact that an activity, which is what we're returning here, we're returning a list of activities, and activity is an interface. So it's actually aware that the activity is an interface in the schema, our schema inspector, and it's telling us that we're missing a mapping for each one of these implementation type for comments. So let's go ahead and add a schema mapping for comments as well. And now you'll notice this, because this is a new feature, it's an interface field. Actually the ID doesn't know that it matches, but if we start this again, you'll see that this time it's all clear. So in order to prove to you that this actually works, let's go to the swim type, and let's say that we change the property here to something else. If we start again, you can see that it's actually telling us that there's a field in the schema on the swim object which is not covered by anything. So that means that it's able to find this and to report it correctly. So in order to understand, this is actually a new feature that we have, that this works for interfaces. In order to understand what's actually happening here is the schema inspection that we have starts by looking at this registration. It knows that there's a controller method registered for this query. Then it looks at the controller method for this query and says, okay, so that returns an athlete. On the schema side, we have a type called athlete, which is being returned. Now it's able to begin to compare these two against each other to see, do they have matching fields and properties? And for some of them, it will find a match. So, you know, the athlete Java type has all of these fields, but it doesn't have activities, right? It doesn't have activities. So now for activities, however, we have another registration. We have another controller method. That's the schema mapping for activities. So now it's able to match those. But from here down, it's actually realizing that this returns a list of activity, which is an interface in Java as well, and so it is in the schema. There's the activity interface, but at this point it doesn't know what kind of objects are going to be returned at runtime, so it doesn't really know what are the objects in Java underneath, and there's no easy way for sure to know what all the types are that can be returned, not without, you know, complex class path scanning and doing things that are not really, they bring their own problems basically. So what we do at this point is on the schema side, it's quite easy to understand what the subtypes are. So we find out there's a run, there's a swim, and there's a rowing type under activity. And then the next thing is we take a clue from this controller method. It's returning the activity interface. The activity interface is in the athlete package. You know, there's a good possibility that the actual implementation types are in the same package. So what if we tried to take the same type name and look for that class in the package? Well, it's there. So now we have a match, and that's how now we can compare again objects to fields. And just to demonstrate that to you, I'm going to move the swim type to a different package, and I'm going to restart. And you can see now that it actually reports one of the subtypes as skipped, because it got to the swim type in the schema and it said, well, I couldn't find the Java type, so that is a skip type that you will have to deal with separately. And I'll come back to that in a moment. But let's restore order. Right, so we have one more thing to add, and then we can run this, and that's the search method. So now we have a search as well, and we can we can go to GraphQL. So this is all right. Let's see. F11, is that better? Can you see in the back the text? Make it a little bigger. Thumbs up. All the way in the back? Very good. Okay. Maybe you have better eyes. Right. So this is a browser-based tool for working with GraphQL. It's actually available to any GraphQL application. There are different, UIs that you can use for that, but we have one that's that we refer to from that's enabled with Spring GraphQL. So I'll show you briefly the application properties. You can see here GraphQL is enabled, and we can serve this simple UI, which we do not maintain or build ourselves. This is sort of a spec, and you can do that with any GraphQL application, as long as you have the UI files. And this is the query for an athlete, and we're specifying, this is the part where in GraphQL we can specify what data we want. We're going to get the athlete first name, last name. We're going to ask for activities, everything. The interesting part is when we get down to activities, we can have different kinds of activities, and some of them have their own fields which are unique to them. So this is where we say, if we get an activity which is run, then we're going to get this field. If we get an activity called swim, then we're going to get these fields, and so on. So let's go ahead and execute that. And it's taking a long time. Okay, so we got the data back, but it took a long time. So let's take a look at the output to try and understand what's happening. So we started at 54, took about 6 seconds. So you can see we're getting an athlete, then we're getting the activities for the athlete, and from there we're getting the comments for each one of those activities. And because we have probably 6 activities in this case, 5 or 6, we're getting comments separately. And all of this is happening sequentially on the same Tomcat thread, it looks like. So we have 2 sins here that we're committing. The first one is that we're making too many controller method invocations. The GraphQL Java engine is making too many control method invocations. It's falling into the n+1 problem, where if you have associations, we're getting the athlete, then we got activities. Now for each activity, if you start getting the comments for each activity separately, then you're going to end up making too many calls for that. The second thing is that we're doing this sequentially, but let's try and deal with this one at a time. We'll go to the athlete controller, and we'll say, we'll change this to a batch mapping. And the way this works is that we're going to take a list of athletes as input, and we're going to return a list of athletes, a list of activities. And we're going to do the same thing for comments, because that is a one-to-many association as well. Okay. So basically, for those of you who don't know, there's a data loader mechanism in GraphQL Java, which means that when we have a one-to-many association, we can take the we invoke, there's a special data loader API that's invoked behind the scenes, and that remembers, instead of fetching the comments immediately, it actually just remembers that you want to fetch comments. When it sees all the activities, then it says, here are all the activities, fetch me all the comments. And that's how it deals with the one-to-many association. Let's go ahead and start this again. What happened here? Okay, so now you can see that we're only getting comments 3 times, and the reason for that is because it is an interface and we have subtypes, so it fetches for each individual type, it fetches them, but it's no longer based on the number of activities, it's just based on a number of for each type of interface. The other thing I want to point out is this is a new feature here. You will see that we have a mapping for comments on swim, rowing, and run. But actually, in the controller methods, we have a mapping for from activities to comments. So that's interface mapping, which is actually turned into individual registrations for each one of the concrete types. So previously, before this feature, what you would have to do is you would have to somehow create multiple of these, one for each type. And if you have a lot of them, so we had some requests where, users came and said, well, can we make many annotations? Can we have a multi-annotation on this that would allow us to express each of the mappings? And we looked at that and eventually realized that actually interfaces mapping is really awkward. So we ended up with this feature, which is working transparently. And of course, if you want to, you can specifically have a mapping from swim activities if you want to do something very specific for that kind of type, but most often I don't expect that to be the case. Now, this is still taking a good amount of time to load, and the reason for that is, let's see, there's about 4 seconds here, 4 different things, because it is sequential. And actually, if we do that, here is, for example, one thing that I realized that I have not mentioned yet even is what's our data layer. We don't actually have a data layer in this because it's not relevant for what I'm trying to show. We have these, instead of data sources, we have this kind of mocked data. So there is using a library called Faker, just getting some of the data is random, for example, for comments, but then a lot of it is hard-coded. So we have all the athletes here I have. And then there are these methods which actually return the data. Like, for example, get activities, get comments. And you can see that each one has a delay. And that's just a simple sleep that makes its way to simulate some kind of a delay. And you can see that when you're fetching a graph, if you're doing things sequentially, that can actually be quite slow. And if we look at the search, that's actually even worse because instead of just finding one athlete, we have multiple results here. We have a couple of different clubs. Maybe we find some athletes, and then from there, for each of those, we need to find activities. Then for all those activities, we need to find comments. So the problem multiplies there. Of course, with batching, it all works better, but still, if we're doing it sequentially, it becomes expensive. So for example, this in particular was Let's see. Yeah, this was 4 seconds, I guess. Okay, so one thing that we can do is we can turn on virtual threads. So that's a property in Spring Boot, and it will enable virtual threads, an executor, into the various parts that are prepared to use an executor with virtual threads, and we have that in Spring GraphQL. Previously in Spring GraphQL, you could look at a controller and you could make it return callable. So any of these methods could return callable. And for us, that was a signal that you want to execute this, and if you give us an executor, then we would make that asynchronous. But now, if you're on GraphQL Java, if you're on Java 21 or higher, and you enable virtual threads, then by default we're going to assume that these kinds of blocking-looking imperative signatures, it means that you want to execute that asynchronously. So let's go ahead and give that a try. Okay, so now if we do the search, it still takes a little bit of time, but this time it's 2 seconds. And mainly the reason for that is, and you can see here that we're executing on different threads. Those are virtual threads. We still need to first look for the athletes, then we need to get the activities, and then from the activities we need to get the comments. We cannot do it in any other order, so there's still some things we need to do one after another. But once we get, for example, to the activities, we can get all the activities for all the athletes, and you can see here all the athletes as input. And then when we get to the comments, we do them one specific activity at a time, but they're done in parallel. So that now that's guaranteed to be 2 seconds, basically, no matter what the query is. We'll just use more threads for it. Right. Yeah, I'll take one question.
But that would mean that compared to normal processing, I'm still 3 times slower, roundabout, than if I would not use GraphQL, right? So I have 3 queries, and in a normal world, I would use step 1.
Yeah, I mean, so the question is that you're 3 times, well, it's 2 seconds. That you're slower than a regular query. First of all, it's not guaranteed that all queries are going to fetch all the data, right? Some of them are going to fetch only the athlete data, so then you're saving yourself fetching the rest of the graph. Also, I'm kind of making it really exaggerated here by adding quite a bit of delay, just so we can notice this delay and see the differences. But it really depends actually on what the operations are. And if you have a graph where some part is expensive and some is not, then it kind of works out, because if it's not expensive, then it comes back pretty quickly anyway. It's just a matter of doing the scatter-gather on the server side. But if there are parts of the graph that are expensive, then you can really keep that fetched only when it's needed. I mean, if you really wanted to optimize, there are ways that you can prefetch the whole graph. You can inject a field selection set into, there's a type called field selection set, and you can actually look at what's being requested, but that's not very common necessarily to do. That's for kind of optimization, more advanced optimization. Right, so I'm going to show you also some client-side access. So I have, for example, a client application. And this is a new feature where we can take the REST client, that's the new blocking REST client, and we're going to create a GraphQL client, which is this can be just a basic GraphQL client, which is an HTTP sync GraphQL client. So that allows us to build a blocking stack client. And then when we actually use it, you can see here that if you're familiar, it's going to look very similar, except there's no mono, there's no flux. We're just specifying the document here, and I'll show you the document, which is basically this, that lives under resources, GraphQL documents. There's a kind of designated place where you can put these queries, client-side queries, instead of embedding them directly in the source. And we're just passing a variable into that, and then we're doing a retrieve and turning it into an athlete. Now, if you remember, on the server side, the graph wasn't fully connected. And here, when I run this, I'm just going to get the athlete data. So I'll talk about that in a moment. But the other thing that I want to show you is that actually with the GraphQL client, the decision that we took is not to create a completely parallel GraphQL client, but we created, we're using the same GraphQL client interface, which means that if you actually want to do something concurrent and asynchronous, even on top of the REST client, you can still do that. So here is, for example, the same synchronous client, which up here we use in a blocking stack way. Down here, we're actually doing it concurrently, and we can do several of these in parallel, and then we can zip them back together. So if you need to do something more advanced and asynchronous concurrently, you can still do that. So the only trade-off there is that Reactor still needs to be on the class path, but you don't need Webflux because REST client is underneath, right? So you don't need Webflux as a dependency. But Reactor, basically you can think of those as kind of the completable future, a more capable completable feature. Plus you can, if you're streaming, you can return a flux and so on. So that capability is still useful, and there is an executor in virtual threads that are used underneath that for the actual blocking, when to offload to make it asynchronous, because the REST client, of course, is blocking. Yeah, so I could run this. Just to show the data comes back. In addition to that, there is an alternative way to do it now with DGS code generation. So DGS has code generation, which allows you to, instead of writing the query like this, it'll actually generate the client API. If you look at the builds, we have the DGS code gen plugged in. Primarily it works as Gradle. That's how Netflix develops it. There is a community Maven plugin as well that you can use. That's maintained separately. And we can tell it to generate client API. So for the query, we can actually do something different. I'll show you over here. So we can say, this is my query, instead of writing it in text. And then I can say, this is the data that I want back. And that's, again, expressed through a Java API. And now once I have these things, I can give it into the DGS GraphQL client. So the DGS GraphQL client is just a wrapper around any other GraphQL client in order to make it a little bit easier to actually pass the query, the projection, and then do the rest of it is basically exactly the same. So it's like any other GraphQL client once you build it, but it lets you use code generation. The nice thing here is that we're getting an athlete, and that athlete is also generated. So I chose to generate the actual domain types as well. And you can see that for example, activity, it has annotations, JSON annotations that will deal and will understand what the subtypes are being returned in order to deserialize correctly. Yeah, based on a type name property that comes back. So if I run that, Okay, this time I get actually all the data back. Right, so what we've seen here is we've seen the virtual thread support, which is new in GraphQL 1.3, the blocking stack GraphQL client with a synchronous API option, but you can still use the asynchronous if you want, and that works both ways on top of a blocking or non-blocking stack, so you can mix and match there. There's the DGS GraphQL client for DGS code gen, and start.spring.io supports that. So if you go there and type DGS, you'll find a couple of options. We support unions and interfaces and arguments in schema inspections. We enhance the schema inspection, also interface field mappings. Another big addition in Spring GraphQL 1.3 is our support for federation. Anybody here using federation? Okay, a couple of hands. So basically, if you want to scale beyond a single service, one option is to use Apollo Federation, and that means that instead of you have one gateway and then you have federated services, some parts of the graph are going to be maintained in one, and some parts of the graph are going to be maintained in another microservice. And then there's a gateway which will actually talk to these other services and fetch the types. I think this is used quite extensively at Netflix as well. And one of the key things there that needs to be supported is when there is a query, if there is a subgraph which is maintained by a microservice, then the gateway needs to make a query to that, and it's called the entities query. And that's something that previously had to be done kind of without any support from us. But this is an example application with Federation JVM. That's based on Spring 4 GraphQL, and I'll just show you briefly here. This is the schema for products, and then product is a federated type. It has this key on which it needs to connect to reviews. And then we have a reviews subgraph, which is a microservice that's going to run elsewhere on a different server. And then if we look in that, we see that product is the top level federated type, and that's being connected to reviews. So there's a bit of extra syntax which is not standard GraphQL. That's kind of federation features. But basically, the gateway may come and say, here are the products that I want reviews for, and then you need to respond to that. And it's called the entities query. So I'll just show you that what you need to do is quite simple. There's a little bit of configuration. We have a federation schema factory that enables this, and there's also a controller. And that controller has an entity mapping method, and it allows you to respond to that entity mapping query, and we take care of the details behind the scenes. So basically the bottom line is that we have built-in federation support now, which is important for those who use federation. Anybody using other ways of doing this, like schema stitching or anything else? Okay. We do have some other features. We did a bunch of enhancements around Websockets for authorization through the connection init method. So we actually have built-in Spring Security interceptors that will help you to do that and then propagate into the controllers the authenticated user. Keep alive, WebSocket keep alive, that seems to be important in situations like you're running a GraphQL service on Amazon, and it's timing you out if there's no activity every so often. So you want to have some sort of a keep alive that's running. In some cases, you might want to configure your JSON serialization differently. For example, it's common in GraphQL if you have a null actually it matters, is it null or not provided at all. So when you deserialize, it's actually important whether Jackson should put null there or just leave it out completely. So there are things like that. I will point out that we have a new examples repository that we've been talking about for a long time. We used to have one back in version 1.0, which was built into the repository, the main repository, but now we split it out. And yeah, so I recommend that you go take a look there. There are links to external samples as well. Okay, so we have GraphQL Java as well with incremental delivery. This is an interesting new feature that started out in Facebook. It's been experimented for a long time. The use case for it is if you picture, say, a Facebook page, you have a number of different posts, and then each post has comments. But let's say because of the volume of data, it's very expensive to fetch comments. So now it becomes important that you want to show the posts first, and then maybe the comments can appear a little bit later. That's not crucial. And then the other thing is maybe it's enough to show 2 comments and then fetch the rest of them later. Now the options to do that is you can make multiple queries, but this really increases traffic. You know, you can say give me only 2 or give me only the posts, and then later give me the comments. What this is about is making a single GraphQL request, but being able to express that some parts of the data can come a little bit later, and then having the ability from the server side to actually send some of the data first and then send some of the data after that. This is now an experimental API in GraphQL Java, but there is a sample project which demonstrates how you can actually do this with Spring 4 GraphQL. And I'll just show you briefly that there is one extra class called the extended GraphQL HTTP handler. So you can just drop this into your project if you want to give this a try. And then in the configuration, there's really a very simple addition that declares this as a bean, and that's pretty much all. And I think there's one other thing here where you have to say it's okay to use an experimental API. Yeah, it's kind of something that you have to do in GraphQL Java to enable this, but otherwise it's pretty easy to try. And how it looks is that in the schema, we have this deferred directive, and that's like an annotation in Java, but for GraphQL. And then this is our graph. We have books and authors. So now if we want to make a query, so let me start this. I'll show you the query. So the query looks like this. I'm going to get a book, and let's say the author is expensive, so I'm going to defer getting the author, and then also I'm going to defer getting another book below that. And the way that this comes back in the response is it comes back as a multi-part response. And the first part is the book. It also has this extra field called hasNext, true. And then the next part comes back and it says this is relevant to the path book by ID, and the data is the author. So that's the author now coming for the book. And then in the third part is actually the second book, and this time hasNext is false, and that's actually giving us in the data the second book. So this is kind of a new mechanism that allows you to prioritize parts of the page, split it up, and then in the query the client can indicate that some parts of the query can come later. There is a working group for this. That's what this link is. There you can find out more information about this. In terms of the HTTP transport, that's just a multi-part response, basically, is the way it comes back. There's a lot more in GraphQL Java 22. They did a whole bunch of performance improvements, avoiding wrapping with execution result for every item with completable feature. I've seen some estimations of 20–30% improvement, so there's quite a bit of good work that's gone into that. There's a schema diffing tool that's being added that apparently is a unique feature, sort of in the GraphQL ecosystem. So if that's something important, take a look. There's a new, this is actually not new in GraphQL Java, but it is interesting, a oneOf directive. So if you have some input and there's 5 possible things, but there's going to be only one of them coming in, there's a way to express that. So it ensures that there's one of these things that comes in. So it expresses that sort of thing in the schema, and then GraphQL Java will validate it when the data comes. Okay, so for the last bit, the integration with DGS. DGS was created at Netflix internally, and they open sourced it. I'm going to misquote, but I think it was around early 2020. And in the meantime, we had started working with GraphQL Java team on a first-class integration for GraphQL in Spring. They used to be an alternative maintained by the GraphQL Java team, but they really didn't have the capacity to take it much farther. So we began to collaborate because we also recognized that we wanted to do something in that space. Then shortly after DGS open sourced, so we continued on our path, DGS continued on its path. Now we're at the point where, you know, we have pretty much feature parity. In fact, we have quite a few unique features. But there's a lot of adoption on the DGS side as well. And this sort of creates two, you know, choices for the community, and that's always a little bit confusing. And it also means that community feedback is, you know, going in 2 different places. So we've known about this, but not much that we could do so far. But we started to talk and to work together, and we made a lot of changes in Spring for GraphQL to make this possible, for DGS to create an integration where on startup they use the Spring for GraphQL API to configure what they need to configure in the GraphQL Java engine, so that at runtime we will use the transports of Spring for GraphQL, so they don't have to create those transports. And it's basically like a Spring for GraphQL application, but it's plugged in with everything necessary for DGS to work as well. So that means that they were able to switch Netflix, which uses GraphQL quite extensively. You can find a lot of blog posts from them, very interesting ones on what they do with GraphQL. And also on this integration with Spring for GraphQL. And it means that they were able to switch their existing applications without the actual applications having to change. And instead, they are running on Spring for GraphQL. And that's interesting, already beneficial for Netflix as well, because there are quite a few transports. We have Spring MVC and WebFlux flavors. We have HTTP, we have WebSocket, we have RSocket. There continues to be innovation in the transport space, the defer directive that I just showed, the incremental delivery. All of this they will begin to get for free. They don't have to continue to develop that. And I believe their roadmap was that towards the end of the year, they plan to run by default with this configuration. So currently, you have to kind of explicitly opt into it, into this integration. And it's also available on the Spring.io. You can find there, if you type DJS, you'll find the client code generation, and also the Netflix DJS integration. So we're very excited about this, and it means that once the application starts, you can create DJS components or we can create Spring for GraphQL controllers, and they can run side by side in the same application. There's even some possibilities, like for example, we have annotated exception handling, you know, like in Spring MVC for GraphQL. It's not something that exists in DGS, but now you can actually use that with DGS components as well. So these kinds of things become possible. And this is the beginning of our collaboration. I'm sure we will have more phases beyond. It's super beneficial for us because we know that this stack is now running at scale at Netflix, so that gives us a lot of confidence. We did have to make some changes, some things they pointed out to make it more optimal. So that already has proven to be beneficial. And again, for DGS and Netflix, it's also beneficial because it means that there's a lot less that they need to do at the transport level. And I think we're out of time, a little bit over. So thank you for your patience and for coming to my session this morning. I'll take maybe a couple of questions if there are any. There's a mic back there. Or you can also come after and talk to me as well. Enjoy the rest of the conference, some coffee this morning and some snacks. Yeah, if you have anything, feel free to find me. Thank you.